Welcome to Astronomy Daily, your source for the latest space and astronomy news. I'm your host, Anna, and we have an incredible show lined up for you today. We're diving into some fascinating developments across the cosmos, from groundbreaking moon missions to mysterious black holes lurking in the early universe. We'll explore Firefly Aerospace's ambitious lunar mission, discover why there's about to be a tiny Swedish house on the moon, and learn about SpaceX's latest record-breaking satellite deployment. We'll also check in on China's historic Yutu rover as it reaches a potential end to its remarkable journey and uncover new findings about supermassive black holes that might be hiding in plain sight. Plus, we're diving into a fascinating revelation from NASA's James Webb Space Telescope. Stay with us as we journey through these remarkable stories that continue to expand our understanding of the universe around us. Let's get underway. Firefly Aerospace is making history with their first ever mission to the moon, set to launch on a SpaceX Falcon 9 rocket from NASA's Kennedy Space Center very shortly. Their Blue Ghost Lunar Lander, aptly nicknamed Ghost Riders in the Sky, carries an impressive payload of 10 NASA experiments, more than any previous commercial lunar payload services mission. The mission will conduct crucial research at every stage of its journey, from Earth orbit all the way to the lunar surface. Before even reaching the moon, the lander will measure solar wind particles and test radiation-resistant computer hardware, while also experimenting with using Earth's GPS satellites for lunar navigation. Once Blue Ghost touches down in Mare Crisium, the real work begins. The landing site was specifically chosen for its smooth, dusty terrain, perfect for studying one of the moon's most challenging features, lunar regolith. This fine, powder-like dust caused numerous headaches for Apollo astronauts, from obscuring their visors to grinding inside their spacesuits and compromising equipment seals. Several experiments will focus on tackling this dusty dilemma. The regolith adherence characterization experiment will test how different materials react to long-term exposure to lunar dust, while the electrodynamic dust shield will attempt to clear away dust buildup using electrical currents, technology that could prove vital for future lunar bases and solar panels. The mission will also probe beneath the moon's surface, with the Lister experiment drilling up to 9 feet deep to measure heat flow, potentially revealing new insights about lunar resources and formation. Meanwhile, the next-generation lunar retroreflector will use lasers to measure the precise distance between Earth and the moon, building upon similar experiments first conducted during the Apollo era. Blue Ghost's 60-day mission will conclude with a spectacular finale as it witnesses both a lunar solar eclipse and an intriguing phenomenon where lunar dust appears to levitate at sunset. A fitting end for a mission that could help pave the way for humanity's sustainable return to the moon. Speaking of things going to the moon, bet you didn't see this coming. The moon is about to receive its first tiny house, and it's not just any ordinary dwelling. It's an iconic Swedish red house with white corners. This miniature architectural marvel is heading to the lunar surface aboard ispace's Resilience mission, representing the culmination of artist Mikael Genberg's 25-year dream. While Genberg initially envisioned a self-unfolding structure standing 8 feet tall, the final moon house has been scaled down considerably to just 3 inches high, 4 inches wide, and 2.5 inches deep. Despite its diminutive size, the structure has undergone rigorous engineering to ensure it can withstand the harsh conditions of space travel and the lunar environment. The symbolic red color of the house carries deep historical significance, dating back to a 16th century paint derived from Sweden's Falun copper mine. For Genberg, this isn't just about placing a structure on the moon, it's about creating a universal symbol that speaks to humanity's eternal quest to explore the unknown. This isn't the first time Genberg has sent a version of the moon house into space. In 2009, Swedish astronaut Christer Fuglesang carried a fold-out cardstock model to the International Space Station, where it was filmed floating freely in microgravity. But now, after decades of preparation, the moon house is finally headed for its intended destination. The tiny house will travel aboard ispace's Resilience lander, targeting a landing site in Mare Frigoris, or the Sea of Cold, in the moon's northern hemisphere. After a 4-month journey through space, this small piece of Sweden will become a permanent artistic installation on our celestial neighbor, serving as what Genberg hopes will be a symbol of humanity's endless drive to push boundaries and gain new perspectives on our world. Moving on now to the company that continues to push boundaries. SpaceX has just achieved another milestone in democratizing access to space with their latest Transporter 12 rideshare mission. Launching from Vandenberg Space Force Base in California, the Falcon 9 rocket successfully deployed an impressive array of 131 satellites into sun-synchronous orbit. Planet Labs dominated the passenger manifest with 36 of their Dove imaging CubeSats and their second Pelican high-resolution satellite. But what makes this mission particularly fascinating is the diverse range of payloads sharing the ride. The United Arab Emirates contributed their MBZ-SAT, weighing in at 750 kilograms and serving as the mission's largest single payload. Among the more intriguing passengers was the debut of Pixel's first 3 Firefly hyperspectral satellites. This Indian startup, fresh off a $24 million funding round, aims to build out an 18-satellite constellation for advanced Earth observation and analytics. The mission also carried some groundbreaking experimental vehicles. Varda Space Industries launched their second mission, W2, carrying a pharmaceutical reactor and payloads for NASA and the U.S. Air Force. Meanwhile, Inversion Space tested their first mission called Ray, designed to splash down off the California coast as a demonstration of precision re-entry technology. Perhaps the most unique payload was SatGus, a 12U CubeSat featuring a video screen that people can upload images to. This selfie satellite takes pictures of the screen with Earth in the background, creating a novel way to engage the public with space exploration. I just might give that a go myself. And SpaceX's Transporter program has now launched over 1,100 payloads to orbit, proving that reliable, affordable access to space is no longer just a dream. While this has been transformative for many startups and organizations, it's worth noting that some launch companies have raised concerns about SpaceX's pricing strategy, suggesting it may be designed to eliminate competition. Nevertheless, the success of Transporter 12 demonstrates how far we've come in making space accessible to a broader range of participants, from established space agencies to innovative startups pushing the boundaries of what's possible beyond our atmosphere. After over 5 years of groundbreaking exploration on the far side of the moon, it appears China's Yutu rover has finally reached the end of its remarkable journey. NASA's Lunar Reconnaissance Orbiter images reveal the rover has remained stationary since March 2024, likely marking the conclusion of what has become the longest operating lunar rover in history. The mission began with a historic achievement when Chang'e 4 and Yutu 2 became the first spacecraft to successfully land on the moon's far side in January 2019. Throughout its operational life, Yutu 2 covered an impressive distance of 1,613 meters across the von Karman crater, surpassing the previous longevity record held by the Soviet Union's Lunokhod 1. The rover's final movements tell a story of gradual decline. In early 2023, its typical drives of 40 meters per lunar day dropped dramatically to just 8 or 10 meters. By October, these shortened further to mere 1 or 2 meter crawls before the rover finally came to rest near a small 10-meter crater, where it has remained since. Despite facing the harsh lunar environment of extreme temperatures, radiation, and abrasive moon dust, Yutu 2 has made significant scientific contributions. The rover discovered materials potentially from the moon's mantle, provided insights into the composition of the ancient South Pole Aitken Basin, and used ground-penetrating radar to study the lunar subsurface. Perhaps most importantly, this mission demonstrated the feasibility of far-side lunar operations through the use of a relay satellite, paving the way for future missions, including China's successful Chang'e 6-sample return mission. While Yutu 2 may have reached its final resting place, its legacy as a pioneering explorer of the moon's mysterious far side will endure in the annals of space exploration. Our universe might be hiding far more cosmic monsters than we previously imagined. New research presented at the American Astronomical Society meeting suggests that astronomers could be missing between 30% to 50% of actively feeding supermassive black holes throughout the cosmos. These aren't your average black holes. We're talking about cosmic giants with masses millions or even billions of times that of our sun. To put their scale into perspective, comparing one of these supermassive black holes to its host galaxy is like comparing a pea to the entire Earth. Yet despite their relatively small size, these cosmic behemoths wield tremendous influence over their surroundings. When these black holes feed, they can blast material away from their centers at speeds reaching a third of the speed of light. These powerful jets can push away the very gas and dust that galaxies need to form new stars, essentially putting the brakes on star formation throughout entire galaxies. The reason we're missing so many of these feeding giants, they're hiding behind the very material they're consuming. Picture it like a cosmic donut of gas and dust surrounding the black hole. Depending on our viewing angle from Earth, this material can completely obscure our view of the feeding frenzy happening at the center. Using infrared data from NASA's Nuclear Spectroscopic Telescope Array, researchers have now created the first detailed census of these growing black holes. While these objects may be invisible to our traditional telescopes, the surrounding dust absorbs and re-emits their intense light as infrared radiation, revealing their presence. This discovery could revolutionize our understanding of how galaxies evolve. As one researcher noted, if our eyes could detect X-rays, the night sky would be dotted with countless feeding supermassive black holes, each one shaping the destiny of its host galaxy. Finally today, let's get a JWST update. The James Webb Space Telescope, or JWST, has been turning heads with its remarkable ability to peer into the depths of our universe. Recently, it captured an image of Herbig-Haro 4647, a pair of actively forming stars located about 1,470 light-years away in the Vela constellation. These stars are in their infancy, and the surrounding scene is a cosmic masterpiece. Imagine a vibrant tapestry of colors and shapes. The stars are enveloped in a disk of gas and dust, which fuels their growth. As they gather material, they also eject jets of energized gas in opposite directions. When these jets collide with surrounding gas and dust at high speeds, they create shockwaves, illuminating the interstellar medium with striking hues of pink and orange. What's truly captivating is the intricate layering of this interstellar material. The image reveals multiple ejections over time, suggesting that these stellar infants have been undergoing repeated outbursts. Each layer tells a story of past interactions, providing astronomers with a timeline of stellar formation activities. The level of detail in this image is unprecedented. Webb's near-infrared camera, NIRCam, allows scientists to observe these phenomena with exceptional clarity, offering insights into the early stages of star development. By studying objects like Herbig-Haro 4647, researchers can better understand the processes that have shaped our own sun and solar system. It's worth noting that Herbig-Haro objects, like 4647, are relatively short-lived in astronomical terms, lasting only a few thousand years. This makes capturing such detailed images all the more significant, as they provide a fleeting glimpse into a critical phase of stellar evolution. The James Webb Space Telescope continues to exceed expectations, shedding light on the complexities of our universe and bringing us closer to understanding the origins of stars and planets. As it explores the cosmos, who knows what other wonders it will uncover? That brings us to the end of another fascinating journey through the cosmos. I'm Anna, and I want to thank you for joining me today on Astronomy Daily. If you're hungry for more space and astronomy news, head over to astronomydaily.io, where you can sign up for our free daily newsletter and stay up to date with our constantly updating newsfeed. While you're there, don't forget to check out all our back episodes. Want to be part of our space-loving community? You can find us across all major social media platforms. Just search for Astro Daily Pod on Facebook, X, Tumblr, YouTube Music, and TikTok. Until next time, keep looking up and wondering about the mysteries of our incredible universe.